This lab is called an investigation of chemical bonds. And in it, we're going to take three commonly found household substances and subject them to heat. And by observing how long it takes these common household substances to melt, we'll be able to conclude something about the strength of their chemical bonds. Generally speaking, the more heat that it takes, either by time or by temperature extreme, to melt a substance, the stronger the chemical bonds there were holding that substance together in the solid state. And the reason for that is to go from the solid state to the liquid state involves moving out of a rigid locked-in bonding position to a position where atoms or molecules are slip sliding past each other. So our substances are table sugar, what you might use to sweeten a beverage; table salt, sodium chloride, what you might use to flavor your French fries; and wax. And what I'm going to do is take these three substances on aluminum foil, because when they melt, they make a mess. And I'm going to set them all on the same hot plate. I've got this hot plate cranked up, and I'm going to just set them on here one by one. And we're going to time how long it takes for them to melt. Probably I'm going to pause the video and then show the after picture so that you don't, it may take several minutes. You probably don't want to watch all of that. So first up, I'm going to put table salt. Then I'm going to put sugar. And then I'm going to put wax, all on the same plate. And actually, we're getting some really good action here right away. So the wax and sugar are melting very quickly. In fact, the sugar, as you can see, is kind of bubbling. It's making a dramatic change. The wax is completely melted. The sugar is partially burning. And so I'm going to pull it off so we don't smoke the place up. The wax is already melted. So that leaves just one substance, the table salt, which I'll give it a few minutes, and then I'll turn the video back on here to see if anything has happened. And then from there, we'll be able to conclude something about the strength of the bonds that make up these substances. Okay, students, so about 10 minutes have gone by. The table salt is still subjected to intense heat, and it is still in powder form. No melting going on. Contrast that with the wax, which melted absolutely immediately, and by this point has reformed and rehardened after being melted onto the foil, and our sugar, which actually cooked after a couple of minutes of being on the hot plate. This is kind of fun. This is like roasting a marshmallow. Let's take a look at our data. So in this lab, we were testing three substances: paraffin wax, table salt, table sugar. To address the question of whether they are ionic or covalent, we're going to simply look at the formulas and ask ourselves, is there a metal in the formula? So I would look on the periodic table and ask myself, is there anything on the left of the stair-step line anywhere in the formula? And if so, it's ionic. If not, it's covalent. So paraffin wax has carbons and hydrogens. Now remember, hydrogen, though it's on the left side of the periodic table, is a nonmetal. So we've got a covalent substance in paraffin wax. In table salt, we have sodium, a group 1 element, which is not hydrogen, and chlorine. So we have a metal in this substance. So we are ionic. And table sugar, we have carbon on the right side of the stair-step line, hydrogen, the lone nonmetal, to the left of the stair-step line, and oxygen, which is to the right of the stair-step line. So that means we've got no metals in that substance either, which means if they're bonded together, we have a covalent compound. Now, if you remember, The wax, because I had that hot plate cranked all the way up, it melted absolutely immediately. The table salt, even after 10 minutes, was still in powder form, not melting. So I'm going to put greater than 10 minutes. Which is enough for us to draw conclusions about the relative strengths of these bonds. And then table sugar, which started cooking, it started charring and indeed melting, but it was a little bit longer than the wax. So I would say like maybe 30 seconds to 1 minute. It was a very quick melt as well. So if we were to ask, about the analysis questions, which compound melted most slowly? Table salt. What does that tell you about the strength of the bonds? Well, by golly, the bonds in table salt are stronger than the bonds in either of the two covalent substances in the wax or in the sugar. Can we draw any conclusions? Well, it seems to indicate, based on this limited sample size, that ionic compounds do have stronger bonds. And that's an important takeaway. And that's kind of the point of this lab. Thank you for your good work.